Hey everyone, welcome back. We've got something exciting to talk about today. SDXL Turbo got released by Stability AI a few days back. In this video, I will be exploring 3 different workflows on how to take advantage of the SDXL Turbo model. First, I will talk about a straightforward text-to-image workflow, where I will show you how to connect the nodes and demonstrate how you can generate an image using the model. Next, I will switch to an image-to-image workflow and show you how to use image-to-image using the SDXL workflow. Finally, I will demonstrate how you can take the low-resolution image, the 512 by 512 image produced by SDXL Turbo model, and generate a high-resolution image in a high-res fixed workflow. For the last part of this video, I will be showing you a new SDXL Turbo UI I made using Gradio and how you can download and use it on your own local machine. I hope you find this tutorial helpful. Let's jump right in. Okay, so first update your ComfyUI installation. Open a terminal and navigate to your ComfyUI installation folder. You can go into your Explorer, the top, click on it and type in CMD. This will open a terminal. Then you can go into update by doing CD, which stands for change directory. Update is this folder. Alternatively, you can open the folder and then go in and type in CMD at the top. And then you want to run the update ComfyUI.bat file. In your terminal, you can just type in update ComfyUI.bat, press enter and let it update. Once it's done, close out, go back to your main ComfyUI folder. You can do cd ... or open a new terminal and navigate back there. Run ComfyUI. The update will continue. Once ComfyUI has loaded, you should be good on ComfyUI side. However, if you've installed the ComfyUI manager and you have additional extensions, you want to go into the manager option and then click on update all. This will update the extensions that you install. So click on update all, wait for it to complete. While you are waiting for the updates to complete, you can go to the ComfyUI GitHub page, scroll down until you see ComfyUI examples, click on it, scroll until you see SDXL Turbo, open the page, and then you will see a link that says download the official SDXL Turbo checkpoint. Click on it and it will start downloading. In case when you click on it, it opens the Hugging Face page, click on the download button here. It is almost 7 gigabytes in size, so you want to make sure you have enough space. Just a quick heads up guys, I am currently in a recovery phase from a recent cold, so you might have noticed that my voice is a little bit different or the audio sounds different. I hope the audio level is correct and you are able to hear me properly. I appreciate your understanding. I did not want to wait until next week to deliver this video, so hopefully you can bear with me as we go through the video. Okay, so once the terminal says that update is completed, close out of the terminal and just wait for your SDXL Turbo model to complete the download. Once the download has completed, you want to go into your ComfyUI folder, ComfyUI, go into models and then go into checkpoints and paste your SDXL Turbo model here. You can close out of your Explorer, go into your terminal and restart ComfyUI. Okay, so once ComfyUI opens back up, you want to click on the refresh button and then make sure that you have the Turbo model in your drop-down list. Okay, so here I have the text to image workflow. I will show you how to do this from scratch. Then I have this image to image workflow that uses SDXL Turbo, and then I have the high resolution fix here. So let's get started and learn how to do it from scratch. For those of you who wants the workflow, you can go into the description below. There will be a GitHub link. Click on it and you will be able to download all 3 workflows. So first we will need the load checkpoint. So we'll leave this here. The clip encoder or the positive prompt can stay. The negative prompt, SDXL Turbo does not make use of a guidance scale or negative prompt. So you can zero it out by simply removing the negative prompt. You can also add a conditioning zero out, which will basically make this 0. Then you can join that into negative. Let's collapse both of these. So these two are the negative clip encoder node. Then we have our positive at the top. Make sure the load checkpoint is pointing towards your SDXL Turbo model. Then empty latent image and be the default one. The SDXL Turbo model was trained on 512 by 512, but like the research paper says, a higher image size work as well. However, the main point of using the Turbo model is that it can generate images in low steps, as low as 1 steps. This means that the images generated by the Turbo model will take little time, as low as 0.1 seconds depending on your machine. Now, if you add an empty latent image that is, let's say, 1024 by 1024, that will increase the time it takes for the model to generate an image. So I will suggest you is sticking to 512 by 512, and then later on you can upscale it using the high-res fix workflow. Now, next, the key sampler will have to go. Instead, we'll be using a custom key sampler. So click on the model, drag out, click on search and type in custom, click on sampler custom. Okay, positive will go into positive, the negative will go into negative, the empty latent goes into latent image. Now, all of the model, we need something in between, which will determine the number of steps. So as you can see here in this sampler custom node, we do not have any field for the number of steps. So click on the model, drag it out, click on search, type in turbo, you will get SD Turbo scheduler, and this will output a sigma. Click on it, drag it into sigmas, and finally we have sampler. So we can take sampler, drag out, and just use the key sampler select one, and this is your default samplers. So you have Euler, ancestral. I'm going to use the Euler ancestral option, and you should have something like this. So we have a load checkpoint goes into positive from the model, goes into SD Turbo scheduler. Then we have the negative from, which is being zeroed out. We have our latent empty image, and we have the key sampler input. And all of these inputs goes into the sampler custom node, which will then output a latent space image. Okay, so this output is still in the latent space. So we'll have to go into the VAE code and then bring our VAE into the VAE code. And this will decode the image and give us something that we can work with. All right, so I changed the positive prop to a colorful monster cute Pokemon star and white background. We'll cube the pet. We'll get the image showing at the bottom here. This is an extension I have, which displays all the images I've generated at the bottom, as well as the image showing here. If you don't see it, don't worry, it's not important. What is important is that we have an image, but it's not great. So we'll have to go into the sampler custom and try to understand what is happening. The first thing that you will see is that we don't have the step count. Instead, it is inside the SD Turbo scheduler. By default, you want to make sure that it is 1. You can go up to 2, but that is the maximum that the paper allows. Keep in mind that the paper is still under research, so it's possible that you can go higher. But as far as the current research is concerned, a single step is enough to generate a high quality image. Next, the sampler custom node. We want to make sure add noise is true. CFG scale, we want to make sure that this is as low as possible. Let's go to 1. Again, we are going to use the same noise seed. Click on generate, and this time you can see we have a clearer image. So for SDXL Turbo model, when you are changing the CFG scale, you're basically telling the model how much contrast you want in your image. If I go lower, so let's say 0.5, and let me create a duplicate of the load image and save this new version. All right, so this is our first one, the second one. Then I will do one with CFG scale of 0.5. You can see now the image is less saturated. It doesn't have that contrast that we have from here. All right, so depending on what is the output that you're getting, you may want to lower the CFG scale or increase it, but just a little bit. You don't want to go overboard as going 2 or 0.5, you want to make sure that you're within 0.8 to 1.2. Now, the model, the SDXL Turbo model, is well trained to follow prompts. As you can see here, the quality of the image, while it is good for a 512 by 512 image, it's not exactly high quality as the research paper tells us here. And we can change the seed here. Let's change the 2 and generate a new one. Okay, so I forgot to change my CFG scale back to 1. I'll try again. So here you can see the output. This is our first image. This is our second image. Now, obviously, we can play around with the positive prompt and try to get a better image out of SDXL Turbo model. But I think the main point of using the SDXL Turbo model is to create a batch, just generate a batch of images, 20, 30, and then you go in and cherry pick the ones that is closely following your prompt and adhere to your particular style that you're looking for. Because remember that it is an SDXL model, so it is trained on pretty much all the styles that are available. Next, let's try to see the image to image. Okay, so here I am inside the image to image workflow, and you may notice that this is pretty much the exact same image to image workflow and that you have as the ComfyUI example page. That is because the image to image actually uses the default key sample. You don't need the custom one for it. So I have an input image here. I have my model loaded. I have my positive prompt. I don't need a negative prompt, so we can clear that out, minimize it. The image goes into a VAE encode. The VAE from the SDXL Turbo goes into the VAE encode node. This will output the latent image, send that over to the key sampler, and of course you connect the model positive and negative as usual. Next, let's try to set the seed to 1. We change the control after generate to fix just so that we can see the progression. Now, the steps count, that one is important. So the way the image to image or SDXL model works is that when you have a denoise, you multiply the denoise by the steps count should end up with 1 or higher. Okay, so if we go back to the research paper, we can see image to image. When using SDXL Turbo for image to image generation, make sure that the number inference steps multiplied by the strength, that's going to be the denoising strength, is larger or equal to 1. Let's take a look at an example. We set this as 1, CFG as 1.0, denoising strength maximum. This is pretty much similar to we are not going to use the load image at all. Click on generate. Okay, so we got an image and it is completely different than the input image. Now, if we want some influence from the input image, we have to decrease the denoising strength. So let's put it to 0.5. And in order for us to get 1, when we multiply 0.5 by the factor, that factor will have to be 2. So 2 multiplied by 0.5 is equal to 1. So we'll set the number of steps to 2 and then click on Q prompt. Now we can see that we are getting something. So this is the original image and this is a newly generated one. So there is a difference here. But let's say we want more variety. So 0.5 is easy. All we have to do is set the steps count to 2. Okay. So here I have steps count as 2 and denoising strength as 0.5. I get this result. If I go to 0.55, as you can see, it's slightly different. If I increase the denoising strength a little bit more, I'll get more variety, but my steps count is still at 2. Now, this is 60, go to 65, and then at 70, we can see that the image changes. Now we don't have enough steps to take the reference image into consideration. So we'll have to go and increase the steps. And if we increase the steps to 3, still at 0.70, the generated image is now taking the reference image into consideration, but with more variation. And as you go up, so let's say we go 0.8 to it, still at steps count 3. And you can see again, we have the same problem. So we'll have to increase the number of steps, which again increases the number of time it will take to generate an image. So at this point, you may be asking yourself, why use SDXL Turbo when you can be using different model? It's an option that you have. So you want to make sure that if you're using SDXL Turbo, you are getting this benefit of having lower time for each generation, and you will have to play with the denoising strength, the steps count. By the way, CFG scale, leave it at 1. You don't want to go too high, you don't want to go too low. Okay, so we've seen the image to image workflow and how to play around with the denoising strength and the steps count. The final workflow is a high resolution workflow, and this one does not use the SDXL Turbo model. But if here I was to do an image to image workflow, get an image, I can send this image to the high resolution work. Let me group it. This part is going to be the high res fix, and this can be your text to image or image to image workflow. The bottom here is text to image. The top one is image to image, and you can click on the Q button, click on the extra options, and then with your cube, let it generate. Once you have an image, you can then connect this image to the upscale image using model image node input. So let's say we connect this over there. Make sure to change your prompt. This is going to be your standard load upscale model. At this point, you can change your checkpoint. So you don't have to use SDXL Turbo as your checkpoint. You can go for any other checkpoint that you have. So realistic vision, deliberate. I am going to be using the universe checkpoint. I'm going to upscale it by 2 times using real ESL GAN X2. And then the key sampler, I'm going to be using 20 steps. CFG scale can go higher now. I can also play with usual denoising strength from the normal workflows. Okay, so let's give this one a go. So click on Q prompt. Okay, so it's completed. Here is the image to image workflow. So input image, we've got a 512 by 512 output. We are sending this output over to an upscaler. In this case, I'm using real ESR GAN. Have the default load model, positive prompt, negative prompt, then encoding that new image. So when we multiply 512 by 2, we get 1024. So we have now a higher image. We are denoising that image by 0.5 using 20 steps, CFG scale 6.5, and this is the output. If I open it, and you can see this is the input and this is the output. So basically, if you have a particular style that you want to generate, but you want to generate as the old SDXL, the default one, the SDXL base plus the refiner, it usually take 2.5 to 2 minutes 30 seconds to all the way to 9-12 minutes sometimes, depending on the number of steps, what I'm adding in between, like IP adapters or control net. But with this, can generate an image within a couple of seconds and keep on generating image, cherry pick anyone that I want. Now we'll have it with the SDXL style, and I can just use any high-res workflow that you have available, put it there, plug it the image, and then generate a high quality image from it. So those were the 3 workflows. We've seen the text to image, image to image, as well as the high resolution fix. Next, I will show you this Gradio application front-end user interface that I made. So at the top, we have the model selection. So we're going to use Turbo. And then, as you can see here, we only have the positive prompt, and click on generate. This will use the workflow, text to image workflow that we've seen inside of ComfyUI, but you don't have to mess up with the number of steps, CFG scale, or any of the other fields that are available there. Just put in your prompt, select the Turbo model, and then click on generate. If I go back into the ComfyUI terminal, you can see here, because I'm loading the checkpoint at the top, again, loading the model, and I have a slow GPU here, so it's going to take some time. All right, so it's finally loaded the model, and you can see by default I have it as 1 step. Basically, it's doing 1 step for you, and we get an image. Now, this image is 512 by 512. I've just displayed it bigger, so 512 by 512 image here. Now, if I go into the tab, image to image, now I have a little bit more. So I have the positive prompt, same. You can use the same output image. So you can click on it, drag it over the tab, and drop it on top of where it says drop image here. This will load the image. And then you have a slider for the denoising strength. Click on generate. Now that I'm looking at it, maybe I should add the number of steps as well. In case somebody wants to go denoising strength of 0.95, they will require some more steps. So I will do that next on the next video. All right, so we get pretty much the same thing. Finally, we have the high-res fix workflow. And in here, there's a lot more that you can change. So we have the positive prompt, negative prompt. You can select an upscaler. You can also select a downscale factor. So for example, let's say you use the real ESL GAN X4. This will multiply the original image 4 times. And if you downscale it by 0.5 and you achieve a 2x upscale, there's the image input. And then you can play around with the denoising, the strength, the CFG sampler. So you can select from these ones. On my next video, I will show you how you can modify the list so you can add more. These are the ones I use, which is why I've added them. But I will show you where you can get it and add it to your workflow. There's also the scheduler. You can select from one here. Then you have your generate button and your output on the right side. At the top, you can select any of the models as previously. So I'll do an example here. So I've selected a checkpoint. I've added a positive prompt, left the negative prompt as blank. I'm using a 2x upscaler. So I will put the downscale factor to 1. It will do 1 multiplied by 2. We are going to get 2x. If I put it as 0.5, it will do 0.5 multiplied by 2. Then I will get only a 1x upscale, basically in the resolution upscaling. The bottom one, we have denoising strength 0.5, steps as 20, CFG as 6, sampler Euler ancestral, scheduler is normal. Click on generate, or wait for it to complete. It's done. So let me open the new image. This is the original image and this is the high-res fix image. So exactly the same thing, just in a, I would say, friendly user interface that you can use. You don't have to worry about the connection, the nodes. Just start the server and it will take care of the rest. I will leave a link in the description below. It's going to be a GitHub repo page, and you can download the entire project there, including the workflows. So your project will look like this. You will have an app.py file, a requirements.txt file, then the workflows will be here. So text to image, image to image, and high-res fix. You don't have to use it. It's just an option for those of you who want a simplified UI. So my next video will be on how I build this. I'm currently making, writing the code for a different project, but it should be up by next week. There's also one thing that I've noted. It would be nice to have like a button here that says send this image over to image, and then maybe another button that says send to high-res fix. I will probably do this next week when I've recovered a little bit more. With that, guys, I hope this video was helpful to you. You were able to learn something and maybe enjoy it a little bit. So thank you for watching until this very end. Click on the like button. Let me know that you've liked this video. If you have any questions or any feedback for future videos or even this video, let me know in the comments down below. If you want to watch similar videos, click on the subscribe button. It helps me, and I will see you in the next one. I want to take a moment to say a big thank you to all of you who subscribe. Right now, my total subscribers is 26. The last video I was at 7, so that's 19 subscribers. Big thank you to all of you. One thing I've noted is that under recent subscribers, when I click on see all, I don't see all 26 subscribers. Now I am guessing that these are only the channel's name, and so if somebody has a Gmail YouTube account but does not have a channel, it's not going to show up here as it says here channel. And then at the top, there's also a quick text that says only includes users who have made their subscription public. So in case you don't find your name here, it's probably because your subscription page is not public, or maybe you don't have a YouTube channel. That's why it's not showing here. But nevertheless, I want to say a big thank you to all of you who subscribe. Thank you.